All right, so guys, Algebra 2, we're in lesson 514, and I do want to tell you this much. Our learning target, you can see that I can solve a quadratic equation by taking or finding square roots. What you want to do as a huge guideline is to always get the squared term alone. Get the squared term by itself. Solve for it. And if you do that, then you're going to be good. After you get your squared term alone, then you take your square roots. There will be two of them. Notice also, this is super important. The first couple problems will be calculator required to get an approximation. And the last problems, we're going to break down radicals rather than approximate them. So let's look at example 1 together here. The squared term is right here. I am highlighting it. And we're solving 2x squared plus 14 equals 102. Let's get x squared alone. So actually, when you're solving, we generally don't undo multiplication or division first. We generally tend to the addition and subtraction first, right? So guess what we're going to start with? Minus a 14. Now, 102 minus 14 is going to get you 82. Sorry, I misspoke. That's really 88, right? 88. So we'd have 2x squared equals 88. Again, we're trying to solve for the squared term. We're trying to get that squared term alone by itself. It's not by itself. There's a 2 there. What should we do? Divide by 2. So, here's the cool thing. You guys have been solving for variables. This is just like solving for a squared term. In the past, like yesterday even, we'd go ahead, we'd take square roots, and then we'd break the square roots down. Now, they're saying go to the nearest hundredth. Here's the real cool part. For this type of a problem, you don't have to simplify a radical. You don't have to break it down with a division tree or a prime factorization. Instead, you're just going to go to your calculator. And by the way, I want to tell you, if you're going to the nearest hundredth, that means you're going to how many decimal places? 2. Look, press mode. Mode is right here next to the left arrow, a couple buttons over. Normally, you're on float. If you turn your calculator on, if you press mode, you're probably going to see float. You can go a couple over here to go to 2. And once you hit enter, this is saying from now on, the calculator will display answers to 2 decimal places. It will round to 2 decimal places for you. So that's important. I'm going to go second mode, second quit. And you can see if I hit square root, second x squared, 44, I'd get 6.63. So plain and simply, now I don't even have to worry about the actual rounding issue. I'm getting plus or minus 6.63. Now, please understand, in ALEKS, you have to separate answers by commas. So you have to type in 6.63 comma negative 6.63. Okay, we doing okay? Okay, so if we come down to number 2, again, notice the directions. They want us to round to the nearest hundredth. So we're going to use a calculator to get some decimal answers at the end, just like we did. We don't have to break down radicals. But here's a very different scenario. You see, what's squared is a little bit more complicated. You can see that it's not just like x squared. Here you have y and a plus 4 in parentheses that's being squared. We need to get that all by itself. So it's not by itself. How do I fix it? What should I do? Add a 32, right? So what you'll have, plain and simple, is y plus 4 squared is equal to 32. Once you get your squared term alone, whether it's one single term or in parentheses, guess what we're always going to do next? Take square roots. Now we're going to get rid of that squared term. So right now I'm going to take my square roots, and by the way, there are two of them. There's a plus minus there. Now, in general, if I gave you radical 32, you would have to simplify it. You'd have to break it down. But they're asking something very different right here. They're saying, can you give me a decimal to the nearest hundredth? So I'm going to just type in square root of 32, and we'll get an answer to two decimal places, 5.66. Now, here's the crazy thing. The left side is y plus 4, and we still have to solve for y. But I want to point out to you that the plus minus, guys, is really two different equations. You see, the right side could equal positive 5.66, but that right side could also have equaled negative 5.66. And if you write it this way, I think it becomes a little bit more clear what's happening. In either of these equations, how would you finish solving? Y plus 4 equals 5.66. Guess what we got to do? Minus a 4. You know it. Heard somebody say that? You get 1.66. Here you minus a 4. It's kind of like losing $5.66 and then losing $4 more. Hey, you had a bad day. You lost $9.66, right? So how would you type it into Alex? Well, you got to separate your answers by commas, and that's really what you have. Okay, we doing okay? All right, so isolate that squared term, take square roots, and then you break it down. The directions for the last two problems change dramatically. It no longer says go to the nearest hundredth. So we're not going to type our square roots in and get decimals. This is where you got to break things down and actually simplify your radicals. So again, here's the big picture idea. You need to get the squared term alone. You have to solve for the squared term. Get it by itself. How do I do that? What should I do? Subtract a 9. And I'll have w plus 5 squared is equal to negative 9. Once we get our squared term alone, whether it's one single term or parentheses, what do we always do next? We take square roots, right? We're going to take square roots. Yes? Yes, it's a negative number. That's a very good observation, Amara. You're absolutely right. You've got that square root of a negative. What does that tell you? You can't have it. So there will be problems where you'd say no real solution. Look, you can't have negatives inside of a square root. If you're worried about that, if you're doubting that, I know I just said a moment ago that we won't type it into our calculator, but if you're worried about saying, wait, is this one there's no solution? You could double check it, and your calculator will confirm that and say that's not possible. So there will be some problems in Alex where you'll see, hey, you know what? There's just no real answer to this problem. We doing okay? Last one. Last one of the day here. Tell you what, we've got this squared term. It's more complicated. I think we can all see it's not like number one where it was just an x squared or one variable squared. We've got to get that green highlighted expression alone. So I'm going to have to do some work. What should I do? Add a 6. Always deal with addition or subtraction first. And you'd say, well, it's a little bit better. It's a little bit better. At least the left-hand side is closer to having that squared term all by itself. But now I've got to get rid of that 2 out in front. And we have to divide by 2. Because isn't that 2 really multiplied to the parentheses there? So the opposite of multiplying is dividing. So I'm going to divide by 2. And hey, now we are going places. At least we've got our squared term alone. What do we always do when we get our squared term alone? We take square roots. We get rid of the square. So at this point, I'm going to break it down. It's so tempting to say, oh, just type it into the calculator and find out what the square root of 8 is as a decimal. No, the directions don't say go to the nearest hundred. We're going to have to break it down. Now, breaking it down, of course, means we're going to do a prime division tree here. Prime numbers are numbers divisible only by themselves and 1. Numbers like 2, 3, 5, 7, 11, 13, and so forth. But I'm going to work on the 8. And I'm going to say, wow, check your smallest prime always. Check a 2. Does 8 divide by 2? Yes, 8's divisible by 2. You get a 4. 4 is divisible by 2. Look at that. You have 2 times 2 times 2. So there are 3 2's in this radical. By the way, the left side's just x minus 3. But I hope you remember when you're breaking down square roots, you're looking for doubles. You're looking for 2 of the same factor. And I do have a pair of 2's. I've got 2 of the same number here. They just happen to be 2's themselves. Whenever you circle something, take one of them out, ignore the other one. What you don't circle, you leave right there. Now, is x all by itself? No, it's not. So I'll tell you what, really, we've got 2 different equations that we're going to have to finish up. The right-hand side, you could think of it as positive 2 radical 2, or you could think of it as negative 2 radical 2. But of course, x is not alone. What do I have to do to finish this up to get x alone? Add a 3. And, over here, I do want to tell you, you could write 2 radical 2 plus 3. I'm going to write this what appears to be backwards. You're going to see this a lot of times in the next few weeks. A lot of times we'll put a non-radical number, like the whole number or an integer, before a radical expression. Don't get me wrong, you could have written 2 root 2 plus 3. Alex would give you credit for it. It's right. But it's good to see that if you just have a term by itself, that's a positive number. It's like there's a plus in front of it. Very similarly over here, I could add a 3. And for sure, you could write negative 2 root 2 plus 3. Full credit. But I'm going to write it a little bit differently. I'm going to put the whole number first, write 3, and then adding a negative is the same thing as subtracting. So these are my 2 answers. I'd have to separate them by commas. And that's all we're really doing today.